All right, let me put this in a slideshow. Okay. All right. So what I would like to divide today's talk basically into the following topics. There are many more topics I haven't covered, but let's start with this outline, and I will touch basically every point here. Probably the last point, I think in the audience, many of you actually are practitioners who work in the. Any questions? You cannot hear any sound. Can people hear the sound?
Yes.
Oh, okay. Other people can. Okay. All right. So that might be your speaker. Okay. So here, first I want to talk about the very exciting breakthroughs in the AI capability in terms of in different intelligence capabilities. And then we will talk about the multi-modal AI, which is the new paradigm of the AI model is capable of, not only in terms of understanding multimodal input, the text, image, audio, and video, and then also generate the multimodal output, the computer can generate text, image, video, and audio. And in each aspect, there are a lot of progress last year in 2023. And then another important methodology improvement is called RLAIF in addition to RLHF, the human feedback. Now we can use AI feedback. And also by end of last year, OpenAI released a paper called the Weak to Strong Alignment. This is the core concern of OpenAI and many other people is how we can introduce the alignment into the language model. Even though human can give feedback, but it's very limited. Also, in the future, AI will become much smarter, become basically superhuman. When they become superhuman, how can we actually align their preference to our preference? So that is what we have to basically tackle. And OpenAI, I think they made they released the first paper, so they had some first step understanding on that problem. And one more, another area I want to touch on is robotics, because robotics, I think it's the next frontier of AI. I think in terms of the abstract thinking, natural language understanding, image generation, we almost reached the end. We pretty much, I think this year there will be more progress in video understanding, but pretty much all the abstract format, modality for human who sit at the desk to do, AI can do now. So what's remaining is for AI to have a physical form and actually interact with the physical world. And that is where robotics is happening. But we also have a lot of progress this year in 2023, and we expect to see way more progress in 2024. And also there is another frontier is the neuroscience and understanding human brains. Now we can actually decode what people see in their brain, but just by observing the brain signals. So imagine we can detect the image, we can detect the speech. So imagine in the future if someone is sleeping and we have a device on their brain, essentially you can observe their dream. That is what's coming, and they're very real. It's actually not science fiction anymore. So all of this progress, and finally, there are a lot of business applications of using the large language model to now the many practical application like customer support, IT support, or many other applications now becomes very easy. So these are the major topics I want to cover. But first, let's take a look at what is happening in last year. So the first thing I want to talk about is the major progress in the large foundational model. So particularly in the large closed form foundation model, they are closed form, but they have the highest capability of AI so far. In terms of the models, in March 2023, OpenAI released GPT-4. We don't know what's inside GPT-4, but I think later people discovered that GPT-4 has 120 layers, has 1.8 trillion parameters, and also uses 16 experts, use a mixture of expert model together with the decoder owning transformer. So that is a GPT-4. It's the largest model by that time. And after that, Google announced Palm 2 to power Bard. We know Palm, its previous version, Palm has 540 billion parameters. So we suspect Palm 2 has a more than 1 trillion parameters too. So it's also a very large model. Then later in September, GPT-4V was released. GPT-4V has a vision capability. So combining vision with text, it's able to process the two modality. It's still based on GPT-4 model. Potentially, it has more understanding about image tokens. And then in early December, Google announced the Gemini, and the Gemini come with 3 sizes: Gemini Ultra, Pro, and Nano. We suspect the size of Gemini is smaller than GPT-4. The reason is Google is taking the approach of training more with more tokens, but smaller models. So it's probably even smaller than Palm 2. This is my guess. We don't know yet, so we don't know what's inside the Gemini. But I think in Jeff Dean's summary of 2023 of what Google's result, he mentioned the smaller model chinchilla they invented, which help us to understand that it's not about the size of the model. If you have equivalent, basically it's a size times the number of training tokens you use. So if you have a smaller size, but you have way more, say 2x training tokens, you can achieve the performance of a larger model that's 2x size. So that is the chinchilla's major contribution. And using that idea, that's why Llama 2 was able to use a much smaller model, but achieve a very good performance. Still not as good as GPT-4 or Gemini, but still very good. So how, in terms of intelligence, how certainly GPT-4, one thing I want to just add is Gemini is a multi-modal transformer that now is able to take image, audio, text, and video. So four modality. The GPT-4V actually can take 3 modality: text, image, and audio. So if now you use ChatGPT, you can interact with voice and you can hear the voice back. So that is the multimodal capability. We will talk a little more later. But in order to understand how far we have come, I just want to first introduce the evaluation data set we use to evaluate the intelligence. So now, if you think about AI, before 2022 is like a toddler. And then in 2022, by the time of ChatGPT is maybe like, and even 2023, I would say AI, the level of AI is like a teenager. It's not yet a college level. So, but we would like AI to really become adult. Adult means like pure the full capability of reasoning intelligence like a human adult. That means the evaluations using a human adult test set, like a college exam. In the college exam, we have biology, physics, mathematics, chemistry, legal, and economics, all kinds of subjects. So it's actually much, if they can pass all of this exam, essentially it's college students with many majors, right? And then we have mathematical reasoning. We use grade school math. There's another math data set. Then we use Big Bench Hard. It's a collection of data set where it's very easy for human, but harder for large language model. So it's particularly designed to test the large language model. Final for human evaluation is testing the coding capability. And then we have a data set from 2021, HALA, SWAG, mainly test common sense reasoning. And finally, by end of 2023, there is a new data set called the massive multidiscipline, multimodal understanding. It's trying to mimic the MMLU, the college data set, but now every question has a multimodal, has both image and text, so make it much harder to pass. So this is the data set. Now let's take a look at the performance we have achieved so far. The human level in performance on MMLU is right now at 89%. So that means Gemini already surpassed the human performance. Maybe we can say by end of 2023, we finally achieved some adult intelligence. The only catch is that we didn't do well. So in terms of mathematics, is also superhuman performance. Now it's 94%. In terms of another math test, we only get 53% in the Gemini. In terms of in the Big Bench Hard, we achieved 83.6. Gemini achieved 83.6. It's not yet human performance, and also in the coding evaluations, now it's only 74. So if you look at this across, and also for HALA, SWAG, GPT-4 already achieved 95%. So I would say half of the, in terms of the evaluation of the adult intelligence, we right now the large language model passed half of the test, but we are still behind in half of the other tests. So that's what we expect to happen in 2024. Is all of this testing, we will have a big jump. That because given the accelerating pace of AI this last year, in 2024 we will see much faster progress. So I'm pretty confident that by end of 2024 we should be able to see a very high performance in each of these tasks. Yeah, that's a good question. Why is the math? I haven't done that research. Probably you can look into that. But already by end of by December, after Gemini was announced, researcher at Microsoft actually introduced a prompt engineering methodology using chain of thoughts to improve GPT-4 reasoning. So they actually achieved make through very intelligent prompting, basically let GPT-4 answer every question with some reasoning steps. With that, they actually now has better performance for GPT-4 than Gemini Ultra. So I want to show that performance. So now the GPT-4 with that prompt engine, the smart prompt, the GPT-4 now achieved 19.1, higher than Gemini Ultra. In the math, it achieved 95. In GSM, the grade school math is 95. which is better than Gemini. In the math, now achieved 68. So before we only achieved 53%. Now with this prompting, we got 68. For big bench hard, we now GPT-4 can do 89%. Still a few percentage not there. For human evaluation coding, now we can achieve 87.8. The job is a reading comprehension, is still a little below. You can see all of this has a 10% jump over what I just described, right? With just a little smart, and this prompting, the prompt engineering method is very systematic. They actually have the whole paper. They also released this code in GitHub, so everyone can actually use those prompt method. And this is, if you search for prompt based, that's the name for the prompting method they introduced from Microsoft Research. So you can see that with this kind of, we already, I would say, yeah, if you take a big bench hard, 89% as a human performance, we have like out of this 7 data sets, 4 are beyond the human performance. That is very good. So we are actually search keyword. Oh, okay. Let me give you the search keyword. It's called the prompt base. Okay. And similarly, you can search for MedPrompt. MedPrompt is a method. It's also released by end of 2023 by Microsoft. It's if you look at Jeff Dean's review article released, I think around December 22, 23, he talked about one of the achievement for large language model in medical domain is Google designed this specialized AI system for medical questions, for medical diagnosis, called the MedPalm2. So they apply PalM2 to all the medical problems, the image recognition, the document processing, and also diagnosis. So then they evaluate on all the medical tests, including the MNLU medical subjects. They showed that they have very good performance. So the Microsoft researcher, using the prompt engineering method described here as MedPrompt in that paper, they basically, as I mentioned, they use the chain of thoughts reasoning and other method. They showed that without any specialization, GPT-4 actually does better than the specialized MedPalm2 in medical domain. So this is surprising and also encouraging, meaning large language model actually perform better than specialized domain model. And it's also a little scary. That means if you are thinking you can maybe outperform GPT-4 or OpenAI in other domain, you probably want to think carefully how you can have advantage, because now if they can just prompt their system a little better, they actually can do better job than a specialized medical system. So this is the major discovery and insight from the last year, both since Microsoft now tied their fortune to OpenAI, so they're very eager to support GPT-4 and OpenAI. But the good news here for us to look at this result is the AI system is very fast approaching to complete adult intelligence. So I think by end of 2024, all the numbers, even the smallest number, 68% should be broken. That's what's coming. So essentially, we talk about artificial general intelligence and also superhuman intelligence. I think by probably in a year or so, that it becomes will become a reality. Okay, so that is just in terms of the intelligence general test. Now, because OpenAI has this closed form model and Google also closed their model, people got very nervous. That number one. Secondly, is using their model have a dependency on their model makes it very expensive and make it also not stable if their system is down or is slow. So many businesses is exploring they're installing their own model. This makes the open source model still very popular, and many people are working on that. The open source model last year went through many versions. I didn't mention a few like before NEMA. The reason is that none of them perform as well as ChatGPT, basically GPT 3.5. Only until Llama 2, it shows that equivalent performance in some aspect as good as GPT 3.5, but still way below GPT 4. I would say 20 percentage point below GPT 4. So it's good enough to use, but still not practical to use. Llama 2 has the large, so let me first just quickly introduce the reason. First, Llama 2 is a much smaller model. It's only 70 billion. The largest is only 70 billion, but it utilizes the fact that it can train over 2 trillion tokens. So take advantage of chinchilla methodology where it collect way more tokens to train the system. So that enabled it to have a better performance. And also it has some model modification with some like GPT-3 architecture, the decoder architecture, and also a better activation function, and also using rotary position embedding, all those small improvement that contributed to Llama 2 has the best performance among the open source model. And we I want to mention it's worthwhile to actually compare the specific performance of Llama 2 to GPT-4 because as a business, if you want to build a product, if you want to deploy something, you do worry about the accuracy. So unless Llama 2 really surpass a certain threshold, it may be still not ideal for you to use that in the practical sense. So and how much you can improve on that in a fine-tuning sense, that is still is an open question. So I think it's good to still carefully compare Llama 2's performance with GPT-4. That's one. Another development I don't they do have a table, but I didn't copy it here. Is a mixture model, mixture 8 times 7B model. So they showed that the mixture has a better performance than Llama 2 in every data set. So if you are using open source model, I think a mixture could be the one to go after. And this is still relatively new, just I think last month. So we probably in our meetup we will take a much deeper dive in this model later. Okay, all right. Now I want to continue from the general AI model to more specific generative model. In terms of generation, I think 2023 is the it has explosion in all the modality generation. First, most visible is image generation, text to image. since the end of 2022, we see text to image, text to video. And so SAM is a segment anything from Facebook, segment anything model, reference model. DALL-E 3 was released in October last year. And the DALL-E 3, the main advance in DALL-E 3 is that before that, people who use Midjourney has to come up with a lot of keywords for the picture to look realistic. And it's very hard to find the right keywords. The DALL-E 3 basically has a much deeper language understanding. It's able to take a complete natural description and convert that into what you want. So that's basically the power of a large language model combined with image generation. And then in the AMU video from Meta, it's now I'll show you the AMU video. I'll show you the later. So this is I give you overview first. The AMU video from Meta basically it's the best diffusion model based video generation. If you want to do video generation, people talk about the Pika, people talk about Imagine video and many other models. But AMU now outperform all of them. So it's that, and also the model architecture is much simplified. It's much more efficient. And so this is definitely, if you want to use a diffusion model for video generation, it's worth taking a look. Okay, excellent. So someone posted the math, why the math is harder. Yeah, but I think that's not a problem for the researchers to tackle this year. The last video model I probably will mention at the end is the Video Poet released from Google in December. It's I think it's the most interesting video generation model because it's not using diffusion model. And I will actually emphasize this more at the end, is what will happen in 2024. Because I'm seeing in 2023, by end of 2023, we are moving away from diffusion model. So even though people are very excited in the last 2 years with the diffusion model, I think 2024 will be the year diffusion model will phase out. And probably many of you don't know why. I'll explain that's why later. So that's my prediction. In terms of speech, and we have the best advance last year. I will showcase a few in this talk. Since January, we were able to use a transformer model to generate any speech in anyone's style. And then in June, Facebook released a voice box. It's taking VAE into another step. Then in end of November, there's two major advancements. One is Lyra. Lyra is a music generation from Google that they can take any artist singing and now you can use the text to generate a scene exactly like that artist with the same vocal voice with the music. And so that's called the music generation. Seamless translations from Meta, where before you translate, you basically convert a speech into text and then translate it into another language. Now, not only you can translate, but also you translate the same kind of voice, the same kind of emotion, the same kind of tone, which is very amazing. So it's like the person, if a person is sad, when you translate, it also has the sad tone, the sad voice. So there are a lot of emotion can add to the translation. Then So you can, this is a very interesting achievement. The last part is audio box. Audio box is released in December, end of December. It's I think if you just listen to the clips, I think personally I am blown away by what it already achieved. So we by now we are generating speech, we're generating translation, but we have not been able to generate any sound just based on text description. So now you can say I'm listening to radio, to ocean sound, and playing with my dog, and that the complete recreation of that sound will be generated. So it basically it's taking similarly to image generation. Now you can arbitrarily generate any sound in nature in what we know in the world. And also that is combined with speech generation. So it's a very general model. I think in our meetup, this is worth to spend one session to really look deeper into how they actually achieve this. And then another part is in the coding part. For open source, we have a star coder in May that's generated a lot of excitement. And then Code Llama based on Llama 2 basically can do coding. Finally, finally in December, another open source Magic Coder showed that they perform better than Code Llama. And then AlphaCode 2, AlphaCode 2 is based on Gemini. Basically, it's not a independent program. It's basically Gemini based, but applied to the source code to the coding competition, and they showed that they're performing better than 85% humans. Remember last year, the first AlphaCode is performing about like 40 to 50, less than 50% of human. But this year is already 85% human, better than 85% of human. So this can continue, the progress will continue. I think we expect that they probably will achieve superhuman performance in a year or so. All right, so that's my, that's a quick summary. I want to showcase some of the music generation. So as you can see here, there are two different artists. And what, so this Lyra is a project, the researcher, Google researcher worked with YouTube business, where they can help the artist when they release something, they can create a shorts. And this is pure AI generated. There's no human composed the music. It's purely based on the text. They trained over the style of the artist. So if you, I want to play this. Yeah. All right. So as you can see, the text, the beginning text is showing that what the user wants to generate, right? So this is the text, and the sound, the artist sound, all these are generated automatically through AI. There's no so basically it's about the content of the sound should be about how offsets attract and how they generate these shorts. So this is one example. Let me show you the next example. Okay, so this is another artist. As if you look at the beginning, the text prompt is what we would like this artist to play. All right. So the music generation has achieved amazing. Oh, you cannot hear? Can people hear my sound? Oh, why is that? Oh, well, sorry about that. It's because of coming from YouTube. All right, let me share the, well, how do I, okay, let me see if I can copy. Well, we will later when we come back to the we can have a website, go to the website to listen. I think from my something was wrong showing the embedded video. Okay, all right, but that will give you an idea about yeah, too bad. This is a music generation, you cannot hear the music. So basically, you can go to just search for audio box by Meta. This is, I think, the best generation result for audio. Is we go beyond the music, the human sound. Now we're going to nature, train, river, bird, ocean, anything you can. And you can even mix dog barking, cat meowing, human baby. You can just imagine anything, and then the sound will be generated for you. So that is the I think just expand our imagination to, like, you can just write a story, essentially create your own audiobook with all the sound effect. That this is what it's about. Not only that, their model is so general, they covered all the previous model, like text to speech. You imagine before, like by end of by I think about July, August 2023, we can pretty much duplicate anyone's speech style, like Steve Jobs, Elon Musk. If you record 1 minute of their video, you can essentially make someone make the AI speaker exactly like that speaker. So that we have achieved. But the nature sound is very different from human sound. However, in the audio box, they were able to do both. They were able to give you the capability of speaking like someone, or let the text speak exactly like you speak. They only take like 10 seconds of audio recording, and then they can duplicate that speech style. They can also add other effect, like if you are speaking in a cathedral, you are speaking on an ocean, they can add many other effects on top of your speech. And also they can make your speech faster, high pitched, different kind of speech expression. So this is I think we will spend this, because this paper is very profound. It has a lot of breakthrough. It doesn't use it doesn't use the traditional model, so it has some innovation in this new paper. So we will spend one session to read that in our meetup. Okay. Now I want to talk about, now it's okay, you cannot hear the sound. For the video, you can still see this video generation. So I mentioned about the AMU from Meta. It's a 4-second video. It's a use diffusion model. And it basically, you can write a text description and the video will be basically generated for you. I mentioned that it is simplified the video generation in 2 steps. Before there are like 5 to 7 steps. Now they just do, the first step is create an image. Second step is animate that image, and plus the text, create a video. So here the image here, they can take any static image and make it into a video. So this is a simple picture. If we, oh, sorry. for the simple picture, they can now create all this audio, all this video, 4-second video out of it. So this is something very interesting. All right, I think there's some text. Okay. In the Zoom share. Okay. We'll do that later. All right. Another thing, as I mentioned that one advancement is the RLHF to RLAIF. So remember, in the reinforcement learning with human feedback, there are 3 steps. The first step is supervised fine-tuning. Second step is training a reward model. In the reward model, we let a human to show the preference for the 2 generated result, which one is preferred, which one is accepted, another one is rejected. And using that, we use that as a reward to train our large language model, use reinforcement learning method. So the major advancement is people discovered that if you replace a human here with a GPT-4 or a good GPT, even 3.5 model, and let that model to select which one is better, you can actually achieve almost equivalent performance. It is slightly worse than human, but maybe just 2% worse than the human. So you can still have very good performance in terms of using AI as a feedback. And this can dramatically increase our training data. So that is a very, very good achievement. The one thing I want to mention is this weak to strong alignment from OpenAI, where the major concern is like our current machine learning is a human teaches a computer. The computer is a student. In the very near future, in a year or so, I think the middle is our future scenario. Human will be here. The machine is much taller, much more intelligent than human. And it's coming. I think by end of this year and the next year for sure, by 2025, it's the machine intelligence will be like this. So how can we make sure? How can we teach the machine to actually align to human preference? Because alignment is about make it talk like intelligently like a human, right? Or give us a result that we would like to have, like politeness or other kind of properties we want. So OpenAI researcher essentially try to duplicate this situation by having a less intelligent machine model to train a current GPT-4 model. So what is the less intelligent model is basically a GPT-2 model. So they try to use a GPT-2 model to align GPT-4 to give us some feedback to train GPT-4. And they showed that with a certain kind of tuning, they were able to improve the GPT-4 relative to before. So basically, they were able to align GPT-4 relative to the preference of GPT-2. But they said that this is a first step, and the result is kind of a little sketchy. It's not like fully explained in terms of the real improvement. However, they were very happy to have this first paper out because before they don't even know how to approach this problem. But now they said it's possible, at least it's feasible. And so, of course, it's remaining to see whether GPT-2, inferior model, could make the performance of a better model worse, right? Because GPT-2 certainly is not as accurate as GPT-4. So that is the concern they have. I recommend reading that paper, but I believe they will come up with a new paper next year, early this year in 2024.
Is the paper title?
The title is called "Weak to Strong Alignment." Yeah, the paper title. all right, I want to I'm very excited about the achievement in robotics. As I mentioned, AI is pretty much in the frontier, pushing the envelope of every intelligent capability. But there's one place we haven't achieved is the robotics. And so this year, the major achievement is in terms of the unifying robotics design. So in terms of what's inside a robot, is now we introduce a large language model combined with vision. Basically, it's a multi-modal language model embedded inside a robot. Because now the robot needs to have a vision, needs to have a language capability. It also needs to have an actuator that controller, it can take action. So now we model those controllers as a tokens. Basically, the token include the image token, language token, and the action token. So the action token now defining the robot action in terms of the angles. So here we have the R and also the speed. And you can actually introduce other parameters, the location. So those controller tokenized combined with language model becomes a unified robot model. So this is a very good achievement. And they show that with this model, the major achievement, certainly for scene task. So in terms of a task you already seen before, RT2 is very similar to RT1. However, for all the unseen object, how to generalize, how to reasoning about the environment, how to learn about the environment, they showed that it has the capability of learning by itself because of the large language model implementation. So this is the achievement in terms of RT2. From RT2, there is another major progress is the introduce a new training data set for embodied robot, based many robotic arms. So here there are 1 million episodes, 22 embodiments, different kind of movements, and also 527 skills, and they shared across 21 institutions. So this is the largest collaboration between university and the industry. And also they retrained RT2 on this data set. So this data set, they hope to really boost the robotic research. With this X data set, the OpenX data set, the RT2 achieved 3 times better performance than the RT2, the previous RT2. So this shows that the data set, a larger training data certainly helps the robots become better. Okay, so that's one. Now another achievement is in terms of a 4-leg robot. Now researcher designed a new training environment, basically like a human Pakao for running. I want to show you just the first few seconds, first maybe 10 seconds. And in this, you can see the 4-leg robot now has this training environment, can jump, climb, and retrain, and basically now you can jump through, right? So maybe I want to show you this, how it climb. It's actually climb down. Anyway, so they created this complete environment to train the 4-leg robot. And finally, many of you already, oh, this is very interesting. It's retrying. It learns to try again and again. Yeah. Okay. So that is the for 4-leg robot training. For many of you already seen this Optus. What I think the best achievement is the actuate, the sensor. of the fingers. And I want to show you just how just in the middle. In terms of the walking, they said they walk much faster than before. So the movement of this two-leg robot is fast. And the last part I want to show is how it's able to. This part is also fun. But the major achievement is the finger touch. So they were able to pick up a bag. Right. So I think that is the true achievement, because so far everything we will worry about the robots is if once they enter the household, can they still can they handle the very fragile object correctly, right? So the able to handle an egg and not breaking the egg, that is I think the best achievement this year. But robot is still far away from being practical. Coming to, I don't know how much of achievement will happen in 2024, but I hope it in 1 or 2 years we probably will make more progress in this. Let me see more. The last part, since we're out of time, I want to show you is this very exciting reconstruction of human brain activities. So the experiment is we let a human watch some pictures for 1 second, and then we record the brain signals. After that, we will use this brain signal to use the image generation method to draw the picture out. And we want to reconstruct what the human just see, right? So this is the goal. The way to do this certainly is basically the mapping from the image, the brain image, to the actual pictures. You can think about essentially use 3 model. One is you train a model, the current image, align the image the brain sees and the brain signal. So you train that image on the training data, and using that you can then generate reconstruct. Basically, this is also this is getting additional data. But the regeneration is happening in the last step. Is using the brain signal now with the aligned model, you can regenerate the image. So you can see some good result. On the left is what people see. On the right is a reconstructed high resolution picture. I think this is a very amazing achievement. It's just 2 years ago, in neural IPS, the picture they reconstructed is like black and white, and most just a very vague shape. Now we can get all the details of the picture and in the color. So this is this kind of fidelity, even though there's still something incorrect. As you can see, the zebra now has a different kind, but the almost identical background, identical foreground, and very close to the reality. So this is a big achievement. All right. Yeah. So what else? There is also speech. I didn't copy the result here. Finally, one thing I want to mention is the video poet. So I don't put it here, but let me just put everyone can look for it. Okay, so the video poet is the last almost the end of December, coming from Google. So this it it goes beyond the it can now generate actually 1 minute video. It goes beyond the MU everyone talking about. So actually, let me show you the video point. Okay, so let me share my screen. All right. So it's not about those cute video it's generated. It's about it's a complete new methodology of generating video. So it remember most video generation so far is using diffusion model, number one. Secondly, it's a text to video. So you give a text, but here it can do all of this: text to video, image to video, video editing, the video to audio, and also it can generate a script to tell a visual story. So this is a 1 minute, video. I hope people can hear the. So this video is completely generated from by the computer, including a story. So the computer write the script and then generate this. Can people hear? Can people hear?
Not the
No?
video.
No.
Okay, that's fine. I think something wrong, but you can see the video. This is the whole story about the raccoon dream about his. You can see the. All right. So you can see the ultimately generating how to tell visual story, how to generate the major achievement is this. You can make a Mona Lisa to young. If you look at the model, it's very different from previous model. First of all, it doesn't use a diffusion model at all. The reason I said diffusion model will go away is because today's large language model needs to integrate all different modality into one big model and then be able to generate different modality from the same model. So what we are going to see is the large LLM, the multi-modal LLM will dominate and will continue to be at the center. So transformer is at the center of all the generation. If we have a different generation model, like a diffusion model, you have to add additional component after the generated from the transformer. So it introduce extra computing delayed time. So what the Google researcher has done is they remove the diffusion model and they use pure large language model tokens inside this model. So this is a transformer-based generation. And so this is, I think, and they work on this for more than a year. There are two papers before this paper become the foundation. One is called the MAC-GIT. I think the full name is. I'll get the citation later. But the major promise is that just using simple transformer token, if we can create a good video token, we can actually just use that for the general transformer to generate videos without using diffusion methodology. So I think given the very good result this video achieved, well, we can, and also very high resolution, much longer time. It potentially will outperform diffusion model in terms of integration with all the other modality of a language model. So this is, I think, this is where the new research direction and the new development is going in the next year. All right, I think we are running out of time. The several things I haven't touched. The two more things. One is the agent model, the so-called assistant model. I think for small, the biggest opportunity for business, for small company, we cannot compete with OpenAI, with Google for the large foundation model or Meta, because you cannot train trillions of tokens. But basically, GPT-3 cost them 63 million to train. Sorry, GPT-4 cost the cost is 63 million, and similarly for Gemini. Most company cannot afford that. So the real advancement is the so-called agent model, where you can actually take action on top of the language model. What do you do after that? I think generated audio, generated video, they are all interesting, but taking action is the most important part. So that's why OpenAI in November released this assistant API. Microsoft has AutoGen. I think in August they released that. Then before that, people use LangChain. All of these tools is helping us to be able to take actions. So what I see going forward is the biggest opportunity if a company wants to get into the AI space is to specialize in certain kind of action where you can actually make the agent do something for people. So that is the thing. And that I think for next year, another thing, the second trend I want to mention is in March this year, 2024, AI Humane, the company name called Humane, is going to release a product called AI Pin, which is sit on top of your. I wrote an article about this. It's a device that can basically talk to you, like in the movie Her. It can answer all your questions. It can do real-time translation for you. It can take a picture for you. Not only that, it can understand the picture and explain the picture to you. So it's like you have someone together with you, watching, observing the world, and it can record a video for you. It has all the intelligence. The intelligence comes from its internet capability connected to ChatGPT. So the Humane is partnering with OpenAI to bring that capability into our body, basically on top of our body. And so I imagine, so Meta has this glass that's already been used in the market, but it doesn't have independent internet capability. So the future, what we see with AI Pin is with internet capability, you can go anywhere. You don't need your phone with you. So that will become a replacement for phone in many ways. Actually, in fact, they demonstrate AI Pin can also take a phone call and can actually call someone for you. So essentially, it has all the phone capability without you actually holding a phone. So that is a coming. That basically makes Alexa, Google Home becomes a little obsolete, because now you can take this device with you everywhere. And imagine that another company create a AI watch, which is different from iWatch, because iWatch still depends on iPhone next to it. So the independent AI device that's capable of making conversation and doing things for you on the fly, essentially it's like the same as in the movie Her. So with that is coming this year. And with that, there will be a lot of new opportunities because now our AI assistant essentially is on our body and can do many things. So with that, I think I want to conclude today's talk, and we can open up for discussions. And I think, yeah, I think I underestimated the time it requires. But I'm staying here. I'm around if you have questions or any